Scientifically, we have 100% certainty that planets similar to Earth are very common in the galaxy. That was accomplished literally in the last 2-3 years, and that many of them are potentially habitable. This is now also established. What we will find on those potentially habitable planets is yet to be discovered, but this is why my topic for today's lecture is other Earths and the possible origins of life. Habitable is defined in two ways. One is quite simplistic but very practical. It is defined in terms of the habitable zone, or the Goldilocks zone, a distance from the star in which a planet similar to Earth orbits on a stable orbit, and that requires a certain amount of heat and energy to reach the planet. So the climate is temperate, meaning that the temperature is roughly in the regime and window where you could have liquid oceans and you could have stable weather and climate. That is called the habitable zone. It is easy to estimate, and that was used for practical purposes in space missions like Kepler, which surveyed to discover such habitable planets. We also know that the habitable zone is a very crude and simple evaluation of the potential for habitability. So in our own solar system, we know that there are moons of the giant planets which are outside of the nominal habitable zone, but are expected to also be habitable environments. So this is probably true for exoplanets as well, but in the future, our attention will be spent on planets which happen to be in the habitable zone and resemble the Earth the best as possible, we can tell. The closest twin to Earth, which means that the planet resembles the Earth in size and conditions, as well as that the star, that is the host star, resembles the Sun, is a planet that was discovered by the Kepler mission. It's called Kepler 452b, and it is a planet which is slightly bigger than the Earth. It orbits its star for about 385 days, as opposed to 365 for our own planet. And the star is practically also a twin of the Sun. So in that sense, this particular planet resembles the Earth, the closest to all of the ones which we found so far. We already have that technology. That is the good news. We haven't applied it yet. Some of it is under development or has been developed but has not been used yet. This is the successor to the Hubble Space Telescope, which is supposed to be launched in 2019, and is a space telescope which will particularly be capable of making a first effort at searching for life on other planets beyond the solar system. So the technology is already there. We call it remote sensing, and it's just a matter of a few years, even months, before we try it. Yes, you're right to say the next decade, because it will take more than just a simple first look at one planet to make such a strong statement. It will take some work to understand the planet first, to understand its atmosphere, to understand its makeup, to understand the conditions on the surface. We have the technology to do that, but it will take a certain amount of work to do this. The second part is it's never a good idea to only do this for one or two or a few planets. So we need a large number of targets and the ability to compare what we find on all of them, and to understand different trends and how different one planet is from another The planets will be in different parts of their history because each one of them is of different age. So all of these factors have to be put together in order for us to have the confidence to understand or make statements about which one of them may show signs of life. Well, in our solar system, it is a really very exciting possibility, because if we were to find any life forms beyond Earth in the solar system, we can take samples and study them very closely and understand much better what life other than Earth life is compared to the remote sensing of exoplanets. So I'm very supportive of the exploration of the solar system for life, and I hope that we increase our effort in this direction because it's a complementary approach to looking for life on exoplanets, and it will be extremely important to human science if we manage to find any such life forms. On the other hand, I personally put my own effort into the search for signatures of life on exoplanets because I think, practically speaking, it's has a higher probability of success. In our solar system, we have very few places left where life as we know it could have emerged and survive. And it is not improbable that in our own solar system we are the only form of life here on Earth, and there is no life on any of those bodies. What is the benefit of studying exoplanets is the much larger sample, hundreds and thousands of possible places. The work in the lab, which is part of this team and High Earth Origins initiative, is crucial and essential to the big goal I was just describing about the search for life beyond the solar system. The reason it is crucial to that effort is because while we have the technology and the techniques of gathering the data on exoplanets, we still don't understand fully the nature of the phenomenon which we are looking for, life. We only have one example, and that's the example of life on Earth, which has developed immensely through the past 3.5 billion years. So it is of paramount importance to know what to look for in the general sense, to understand some of the basics about the photochemistry of the molecules which lead to life and lead to the early existence of life on a planet like the early Earth. And what we do in the lab is exactly that synthesis driven by UV light from the sun. In the lab we actually simulate that light from the early sun and study the chemistry that takes place under conditions which are natural for a planet like the early Earth. That brings us to the building blocks for proto-primitive cells. And those primitive cells, when we have a chemical system that behaves like a cell, will be able to tell us what are the planetary conditions that could make it happen or not, and what do these planetary conditions look like compared to what we see through our telescopes. So the two efforts intricately related to each other, in fact, depend on each other. I do think that it is worthwhile, and I support people who actually have reinvigorated that effort in the last couple of years. And the reason for that is because what we found in the last few years, mostly through Kepler and other surveys, is that planets like the Earth are very common, much more common than what we thought before. And some of them are not that far away from us. So if life is a robust phenomenon that could emerge and sustain itself and evolve on a planet that could happen quite often in our galaxy. And then it's logically to expect that in some of those cases, the complexity of life led to species that could control their environment and transcend the planet in ways in which we have through radio and other telecommunications. So our own technology now allows to detect this kind of signals, weak signals or leaking signals from the development and the control that such biospheres may have on their environment. So it is worthwhile to try. It is a very challenging project even today with our best technology because of the issue of distance, but also the issue of probabilities which are not well defined. Under what conditions and for how long will such civilizations or signals exist in the bigger picture of our galaxy. But the probability is not zero for detecting them, so it is worthwhile to try. I personally would not put all our effort in that direction, and that's why my own effort is into the detection of microbial biosphere signatures, which should be much more robust and much easier to detect. But the people who are trying to do this actually doing very solid science and engineering. It is a revolutionary thing when you think of it. This is one of humankind's biggest questions, has always been. You know, there are probably three of those, like what is the nature and origin of the world, of the universe, space, time, and matter. Then what is the nature and origin of life? And then thirdly, what is the nature and origin of consciousness, the brain, and how all that works. So this is one of those three big questions, and suddenly we will have answers where before we had none. Is it a new Copernican revolution? In a sense, it's the completion of the Copernican revolution itself, because essentially the Copernican revolution told us that the Earth is just a planet around a star, and there are all these other stars there. So the logical conclusion was, oh yes, so there may be many Earths, and so there may be many civilizations or life on those other planets. Except we have no evidence for that to this day. So it's 400 years later, and we still haven't completed the logical conclusions of the Copernican revolution. But I think it is a new milestone and revolutionary for humans in general, because it really relates to who we are and our own place in the world in a way in which we haven't done it ever. On one hand, it tells us that we are not alone and somehow unique in a world which generally has no place for life and creatures like us. So that's very comforting. On the other hand, it also gives us an opportunity to understand ourselves through the question of the other in a much bigger way. The question of the other has always been, who am I with respect to other humans that I've never met before on other continents? Well, this is over now. I mean, planet Earth we all one. We know each other. There is no other to encounter there. So this is our next big possible encounter. And humans always look forward to that, because that's how they, in a sense, define themselves. So that is a very different revolution from Copernicus, and yet in many ways it's as important as this. My answer to that is yes, but not necessarily for the same reasons. I think humanity or humans have it in their nature to explore and to go other places. whether they need to or not. And so plan B may not be plan B. For many people, it may be plan A, because they want to be there and not because they have to be there. Humans have done a lot of both in their history, and I don't see why we will stop. So when people say we want to go to Mars and live on Mars, they really mean it, even if it's perfectly fine to preserve and make life on Earth better. There still is the drive to go and live somewhere else as well. So to me, there is even a much more positive way to look at this. We will go and explore beyond Earth, even if we don't have to. And we should preserve and have Earth as nice or nicer than it is for now, and still go and explore. So I'm a big believer that this will happen. And in fact, with respect to Mars, I think it will happen in our lifetimes.